Okay, hi. So I spent month building a 5 different AI systems, tested them on 132 legal queries from the Indian Penal Code, and the system I expected to win came dead last. Yeah, hi. I am Vijay R from Department of Information Technology from Savita Engineering College. This is my research on hybrid retrieval with MMR for legal documents. And this is the next 5 minutes. I will walk you through exactly what I built and how I tested it, what the numbers actually show. Let's get into it. The section one is going to be the research question. First, what is this research? It's an information retrieval application study. Basically, I asked one question: which search method works best when the documents are Indian legal text? The corpus I'm searching is the Indian Penal Code 511 sections, plus the brand new Bharatiya Nyaya Samhita 2023, which is the updated replacements for IPC. Around 633 legal classes total. And I created a benchmark of 132 queries across the difficulty levels. Best exact queries where you use proper legal language like punishment for murder, paraphrase queries, casual restatements like deceiving someone to get money, conceptual queries where you need reason like when can some legally kill in self-defense. Yeah, these 5 systems, 132 queries. Let's see what wins. Before that, let me walk into the dashboard open. This is our benchmark overview. These are the metrics we use, the best NDC, the map at 10, MMR, recall, and corpus size. This is the 633 corpus size, including the IPC 575 and the BNS 558. These are the results we get on the graphs, the metrics comparison by system to system, and the accuracy versus latency, and change versus vector only. With the hybrid MMR, we get something. It's all later on we can see. Now, moving to the 5 systems, what I built. One, BM25, classic keyword search, was like eagerly Google, fast no AI. So second one is TF-IDF, another keyword baseline, weights rare terms higher, old school NLP. And the three, vectors only. This is a semantic search. I encoded all 633 classes into 384 dimensional embeddings using the all-MIDI LM L6 and B2 model, stored them in a FAISS index. When you search, it finds classes by meaning, not just matching words. And then fourth, hybrid, no MMR here. This fuses vector and BM25 scores together. 60% vector and 40% BM25 should combine the best of both worlds. And next is going to be the fifth one and the last one, hybrid plus MMR. The full pipeline, hybrid fusion for top 50 candidates, then maximal marginal relevance re-ranking, that's called as MMR, to balance relevance and diversity. This was the flagship system I designed. I measured precision at 5, recall at 5, NDGC at 5, map at 10, and MMR, standard IR evaluation metrics. This is the complete dashboard. Here are the top 10 matches we are getting. It's set at 5 and the MMR lambda score is 0.90. We can change it and get accordingly the results how it changes. The fusion is going to be 620 and I included a thing query rewriting for some of the conceptual queries. When we rewrite with the proper legal terms, we can get more accurate answers. So I introduced query rewriting. It's a part of a research, how it enforces and changes that 5 systems and accordingly how it performs. So it's also in the research. And these are the systems info. It's a legal class actual benchmark. So overall benchmark of the 5 systems and systems graphs comparison, speed versus security, per category breakdown like Sapphire fields, like the system metrics for the 3 query types, exact terminology, paraphrase, and the conceptual, all the 3 There is a one winner of no. It's a vector only at 3. He's dominators here. And the winner for the exact terminology is BM25. When we give the exact terminology, there is a mode for reasoning or this understanding of that text. So it captures that exactly what we needed, we given, and what we needed, we getting. That's BM25, the keyword search. So these are the metrics I'm getting by that. So the corpus quality impact, PDF extractor, and clean JSON. So let's see. This is the most important empirical finding of this work. Data quality, where the data quality dominates the algorithm choose for legal retrieval. So we need to properly embed and split into classes before on the pre-processing. It works and gives a 22.2% recall and 26.9 at MMR improvement. So before the PDF extracted and PDF plumbers, that's 87. When the clean JSON curated, it's 312 characters. So the practical recommendation here is to before optimizing retrieval algorithms, invest in structured, curated corpus construction, PDF extraction, produced 455 classes, averaging 87 characters, far too short for meaningful semantic retrieval. The curated JSON corpus is, and these are the things here, and the full application results and things. These are the overall dashboard. Here I mentioned. Then move to the results. Going into this research, I had three assumptions. One, hybrid fusion should be the single system search. Two, adding MMR should improve the hybrid system. Three, the more stages in the pipeline, the better results. Every single one was wrong. Here the actual recall of numbers. BM25 only 0.659 and TF-ID 0.291. No MMR 0.609. Hybrid plus MMR 0.568. Vector only 0.773. The vector only wins by a lot. The simplest AI system, just embeddings and FAISS, beats a full three-stage hybrid pipeline by the 17 percentage points. NDG tells the same story. Vector 0.603, hybrid plus MMR 472, and MMR is 0.545 versus 0.484. This is the statistical significant. I confirmed it with Wilscon signified rank test, two-sided at alpha 0.05. So why does MMR hurt accuracy? Because MMR diversifies the results. It deliberately pushes similar classes out of the top 5 to include something from a different part of the law. That's great for exploration. But when your metric is did the correct section appear in the top 5, diversity is a penalty. I also found that BM25 and paraphrased queries only 32% recall on exact legal queries. 83%, 83%, that's a 2.5x gap. Completely break down the moment someone doesn't use statitude language. And I tested world dot based query expansion as a naive baseline. It made vector call drop 8%, more noise, but not more signal. So what's the takeaway from all this? If you are building a legal retrieval system where users type formal legal terms, BM25 is the fast, simple, and works well. But the moment users type natural, informally, the way normal people talk, dense vector retrieval is the only system that generalizes. Hybrid fusion doesn't automatically beat individual systems. MMR traits accuracy for diversity, useful for UX, but you need to know the cost and completely doesn't equal performance. Measure everything. I have opened the full project, the corpus pipeline, the file retrieval system with 132 query benchmark, evaluation scripts, Wilson testers, sensitivity analysis, and the research dashboard. GitHub link is in the description. Yeah, hi, this is Vijish Durai from IT department, Savita Engineering. If you are into NLP, information retrieval, and legal research, here to comes to the part. Let's move into the demonstration part. Before that I mentioned this is the benchmark overview, and for your reference I included the pair system analysis where you can choose the system what you gonna compare with. Like if I want to compare with dense and hybrid, I can compare and select the query. So this is the default queries here. So instead of running the system, it's typed there, and now I'm comparing it. It's still running here. We can wait for some more times. Let's see what's happened on the back end. This is the overall. This is the overall hierarchy of these folders. How this happens, and these output diagrams where I'm projected. It all comes from our research. Let's check. Now it's running the ratio comparison. Yeah, here it comes. The query intersection BM25 and retrieval performs similarly on the query balance. So based on the comparisons, it will give us scores and results. You can learn and what are the query and what are the results is fetched and retrieved from the knowledge base. It shows here, and this is the graph metric. What, like, let's research the query relating impact. Let's say, okay, let's say here, um, I'm assuming if my wife asks me money for divorce, I'm just typing randomly and putting a informal way of query how it gives the response. Let's see how it shows the response. It says, I'm assuming if my wife asks me money for divorce. It's an informal way, it's not in a proper context. Let's see the query relating how it works. Running with that without rewriting. So here, okay, there's a one bug. The Olama is not running. So first we run Olama. Here Olama, Olama search. Okay. Now the Olama is running. So let's see. Now let's analyze again. Oh, we got punishment of culpable. Okay, it's also an example. So he got the related query as culpable homicide causing death intent. So how it shows the result? Before no right, it shows 1111, but in the BM25 R at 5, it shows 0.333 and improves 7 around 8% at BM25, gets 0.167 extra, and here 0.83 and TDS. So we can see here a drastic improvement on this. So for this, we introduce the query rewriting and the grounded assistant to test how we get the answers like a chatbot system. So this is the main application code area. It's not of the part retrieval evaluation, just to show you how this can help the chatbots to get more accurate answers. For example, if I murder someone, what will happen? Here we are using GPT OSS 120 Cloud for the citations and Gemma 340 for the relate model. So here's the result. The punishment for culpable homicide not amounting to murder. Okay, the legal question is changed, but the result is pure 100%. These are the things spreadsheet. So good. This is about our research, why hybrid retrieval, evaluation metrics explained, experimental settings, how we can change and how it changes. So all are here. And this sensitivity analysis, overall graph and how it changes. When you change the sensitivity, how the system reacts. All the part of this research are encoded here. Let's check my description for the GitHub link. Okay guys, thank you for watching. Bye.